Complex numbers. EAMCET 2023 problems and solutions. This is TS EAMCET problems. Here I explained. This is first question. Here is given argument of sine 6 pi by 5 plus I into 1 plus cos 6 pi by 5. This is the given. We know that the formula argument of x plus iy is equal to, this is the formula, tan inverse of y by x. This is the formula. Applying this formula, that is tan inverse of y, here y is I coefficient, that is 1 plus cos 6 pi by 5. So this 6 pi by 5 is written as pi plus pi by 5 by real part, that is sine 6 pi by 5. This is written as pi plus pi by 5. So that is equal to, this is tan inverse 1 plus cos 180 minus theta. This is third quadrant. This value is minus cos pi by 5 by sine of 180 plus theta. This is minus sine pi by 5. So that is equal to, this is tan inverse of, this value is tan inverse of 1 minus cos pi by 5. This is written as, this is the formula, this is 2 sine square pi by 10. 1 minus cos 2 theta is 2 sine square theta. This is minus sine pi by 5 is, this is 2 sine pi by 10 cos pi by 10. Here 2 cancel, 1 sine square sine pi by 10, sine pi by 10 cancel. So that is equal to, this is tan inverse of minus, this is sine pi by 10 by cos pi by 10. This is tan pi by 10. Tan inverse of minus tan pi by 10 is equal to, this is pi minus, this is tan inverse of tan pi by 10. Here tan inverse tan cancel, that is equal to pi minus pi by 10, that is equal to 9 pi by 10. This is the required answer. This is second question from complex numbers. This is EAMCET 2023. EAMCET 2023. Here is given 1 plus I cos theta by 1 minus 2I cos theta is purely real. Purely real means imaginary part is equal to 0. Imaginary part is equal to 0. Then find the value of cos cube theta plus sin square theta plus cos theta plus 1 is dash. This is given purely real, that means imaginary part is 0. Here given problem is, that is 1 plus I cos theta by 1 minus 2I cos theta. So take rationalization, this is 1 plus 2I cos theta by 1 plus 2I cos theta. We are taking imaginary part. Imaginary part means here real part is multiplied by imaginary number. This is this one, and here real part is multiplied by imaginary part. These are the imaginary part. 1 into 2 cos theta, that is 2 cos theta plus 1 into cos theta, that is cos theta, is equal to 0. This is the imaginary part. That is imaginary part. So denominator value is total a plus b into a minus b. This is a square minus b square. This is all real part. So this is 3 cos theta is equal to 0. From this cos theta is equal to 0. Cos theta is equal to 0 means theta is equal to pi by 2. Substituting theta value in this equation. So here is what we finding, that is cos cube theta plus sin square theta plus cos theta plus 1. Now we find this value. Here theta is 90, cos 90 is 0, sin 90 is 1, this is cos 90 is 0 and plus 1, that is equal to 1 plus 1 is equal to 2. This is third question from complex numbers. Here is given I is equal to root over minus 1. Then sigma r is equal to 0 to infinity I by 3 whole to the power of r is equal to dash. Now we find this value. So substituting r is equal to 0, that is I by 3 whole power 0 is 1. R is equal to 1, this is I by 3. r is equal to 2I by 3 whole square, r is equal to 3, this is I by 3 whole cube, plus up to dash dash infinite terms. So this is infinite ZP, that is S infinity is equal to A by 1 minus R. Here A is first term, so that is 1 by 1 minus R, common ratio is I by 3, that is take LCM, this is 3 by 3 minus I. Take rationalization, this is 3 plus I by 3 plus I, that is equal to 3 into 3 plus I by, this is in the form of A minus B into A plus B, A square minus B square, that is 9 minus I square. Here I square is minus 1, that is 3 by 3 plus I into, this is 9 minus of minus 1, this is 10, that is equal to, this is the answer, 3 by 10 into 3 plus I. This is the required answer. This is fourth question from EAMCET 2023 in complex numbers. If here is given z is equal to x plus iy is a complex number such that z bar cube plus z bar into z cube is equal to 350 and xy are integers, then find mod z. We know that mod z, so mod z is equal to, formula is under root of x square plus y square. This is the formula, mod z. Here z is given x plus iy, mod z is equal to under root of x square plus y square. Now we find x and values from this equation. Here is given z bar cube plus z bar z cube is equal to 350. Take z and z bar common. This is z bar whole square plus z square is equal to 350. This is z into z bar. We know that the formula, that is z into z bar is equal to mod z whole square. This is mod z square into z bar. Z bar means conjugate complex number, that is x minus iy whole square plus z square. Z is x plus iy. This is x plus iy whole square is equal to 350. So mod z square, that is mod z square is x square plus y square into, this is in the form of a minus b whole square plus a plus b whole square, that is 2 into a square plus b square, that is x square plus I square y square is equal to 350. Here is 2 175 times cancel, so this is x square plus y square into, this is x square, here I square is minus 1, that is x square minus y square is equal to 175. This is written as x square plus y square into x square minus y square is equal to 175 is 25 into 7. This 25 is written as, that is 16 plus 9, and this is 7 is written as 16 minus 9, that is 16 minus is 7. From this x square plus y square is equal to 25. From equating these two, that is x square is equal to 16, y square is equal to 9. Now we find mod z. We know that the formula mod z is under root of x square plus y square, that is x square is 16 plus 9, that is equal to root 25 is equal to 5. Therefore mod z is equal to 5. This is the required answer. This is fifth question from complex numbers. If z is equal to 3 plus 2i sin theta by 1 minus 2i sin theta is purely imaginary number, then find the value of sin square theta plus cos square 3 theta. Here is purely imaginary number is given. Purely imaginary number means real part is equal to 0, equating the real part to 0. So take rationalization for this z. This is z is given 3 plus 2i sin theta by 1 minus 2i sin theta. Take rationalization. Rationalizing factor is 1 plus 2i sin theta multiplying and dividing by this value, 1 plus 2i sin theta. Now real part, here is 3 is multiplying by 1. This is one real part, and imaginary part is multiplying by this imaginary part. So 3 into 1 is, that is real part is equal to 0. That is 3 into 1 3 plus 2 sin theta into 2 sin theta, that is 4 sin square theta So I into I minus, this is minus 4 sine square theta. Minus 4 sine square theta is equal to 0. And from this, so 3 is equal to, from this 3 is equal to 4 sine square theta. So from this sine square theta is equal to 3 by 4. This is sine theta is equal to root 3 by 2. That means theta is equal to 60 degrees. Substituting 60 degrees in this equation, now we are finding that is sine square theta plus cos square 3 theta. Sine square theta, theta is 60. This is sine square 60 plus cos square 3 into 60 is 180. Sine square 60, that is root 3 by 2 whole square is 3 by 4 plus cos 180 is minus 1 whole square is 1. 3 by 4 plus 1, that is equal to 7 by 4. That is the required answer. This is sixth question from complex numbers. The locus of z such that mod of z minus I by z plus I is equal to 2, where z is equal to x plus I by. Now we find the locus of this. Here is given modulus of z minus I. This is modulus of z minus I by z plus I is equal to 2. From this, mod of z minus I is equal to 2 into mod of z plus I. Substituting z is equal to x plus I y. This is x plus I y minus I, that is equal to 2 into mod of x plus I y plus I. This is modulus, that is mod of x plus take I common. This is y minus 1, that is equal to 2 into mod of x plus take I common. This is y plus 1. So modulus, that is under root of x square plus y minus 1 whole square is equal to, this is 2 into root over x square plus y plus 1 whole square. So squaring on both sides, that is x square plus y minus 1 whole square. Y square minus 2y plus 1 is equal to, this is 4 into x square plus y square plus 2y plus 1. That is, so multiplying by 4, this is x square plus y square minus 2y plus 1 is equal to, this is 4x square plus 4y square plus 4 2s are 8y plus 4. Here is 4x square minus x square. This is 3x square, 4y square minus y square. This is 3y square, 8y plus 2y. This is 10y, 4 minus 1, that is plus 3 is equal to 0. This is the locus of the z. If I is equal to root over minus 1, then argument of 1 plus I whole to the power of 2025 by 1 minus I whole to the power of 2022. This is the question, argument of this value. So we know that the formula, that is 1 plus I by this is 1 plus I by 1 minus I. This value is equal to I. Or 1 minus I by 1 plus I. This is minus I. Remembering these two formulas. Here is given 1 plus I whole to the power of 2025. 1 plus I whole to the power of 2025 by 1 minus I whole to the power of 2022. This is equal to 1 plus I whole to the power of 2022 plus I whole cube. This 2025 is written as 22 plus 3 by 1 minus I whole to the power of 2022. Here this value 1 plus I by 1 minus I whole power 2022 is I to the power of 2022 into 1 plus I whole cube. This is a plus b whole cube, that is 1 cube plus 3I plus 3I square plus I cube. I to the power of 2022. This is I square into 1011. I square value is minus 1. So this is 1 cube is 1 plus 3i, 3i square minus 3, I cube is minus I. So I square is minus 1 whole to the power of 1011. This is minus 1 into, this is 1 minus 3 minus 2, 3i minus I. This is plus 2i. So multiplying by minus 2 minus 2i. Now we find argument of this value, argument of 2 minus 2i. So argument of x plus iy is equal to, this is the formula, argument of x plus iy is equal to tan inverse of y by x. This is the formula. Here is, this is tan inverse of y, this is minus 2 by 2, 2 cancel, that is equal to tan inverse of minus 1. So tan inverse of minus 1 is equal to, this is minus 5 by 4. This is the argument of given problem. This is 8th question from complex numbers. Here is given, if I square is equal to minus 1, then 1 plus root 3i whole to the power of 2022 minus root 3 minus I whole to the power of 2022 is equal to dash. So here is given 1 plus root 3i whole to the power of 2022. So for this multiplying and dividing by 2, this is written as 2 of 1 by 2 plus root 3 by 2 into I whole to the power of 2022 minus, this is also multiplying and dividing by 2, this is root 3 by 2 minus I into 1 by 2 whole to the power of 2022. That is equal to, this is 2 power 2022 common in both, that is 1 by 2, this is 1 by 2 is written as, this is cos pi by 3, cos 60 1 by 3, 1 by 2 plus I into root 3 by 2, this is cos 60 pi by 3 whole to the power of 2022 minus, here root 3 by 2 is written as cos pi by 6 minus 1 by 2 is sin pi by 6. This is also whole to the power of 2022. 2 power 2022 is common. Now applying DMAS theorem for this, that is, this is equal to 2 to the power of 2022. So this is cos, applying DMAS theorem, 2022 pi by 3 plus I cos 2022 pi by 3. So minus cos 2022 pi by 6, minus into minus plus I sin 2022 into pi by 6. That is equal to, this is 2 power 2022. This is 2022 pi by 3. This is 3 cancel, 6 3s are 18, 22, 7 3s are 21, 4 3s are 12. This is cos 674 pi plus I cos, here is 3 cancelled, this is I, this value is sin, this is also sin, this is sin, this value is, that is 674 pi minus cos 2022 into pi by 6. This is written as cos 6 3s are 18, 22, 6 3s are 18. Again this is 6 3s are 3, this is 3 3 7 pi plus I into, this is also sin 3 3 7 pi. So multiplying, dividing by 6, we get this 337. So that is equal to 2 to the power of 2022 cos of 674 pi. This is even number, this value is 1. Here 674 is even number, so cos pi value is 1. This is sin 674 pi, this value is 0, sin pi is 0 minus cos 337 pi. This is odd number, this value is minus 1. 337 is odd number, so cos pi is minus 1 plus I into sin 337, this value is also 0. That is equal to 2 to the power of 2022 here into 1 minus of minus 1, this value is 2. That is equal to 2 power 2 to 2022 into 2 power 1, that is equal to 2 to the power of 2023. This is the required answer. This is the ninth question. If the value of root over minus 5 minus 12i plus root over 7 plus 24i is a negative real number k, then k is equal to dash. Here this is square root is given. We know that the formula square root of a plus ib is equal to, this is the formula, plus or minus x plus iy, where x is equal to under root of, this is under root of a square plus b square plus a by 2, and y is equal to square root of, this is a square plus b square minus a by 2. This is the formula for finding the square root. Now here first square root value is given, that is root over minus 5 minus 12. Here a value is minus 5, b value is 12. So that is equal to, is plus or minus under total under root of a square plus b square, 5 square plus 12 square. This is 25 plus 144 plus a value is minus 5. This is square root by 2 plus I into y value, that is, this is square root of a square plus b square. This is also 25 plus 144. This is minus a means plus 5 by 2 plus 7 plus 24i. This is also plus or minus under root of 7 square 49 plus 24 square 576 under root plus 7 by 2. This is plus under root of 49 plus 576 minus 7 by 2 under root. So here 25 plus 144, this is plus or minus root 169 is 13. This is root over 13 minus 5 by 2 plus I into, this is 13 plus 5, this is 18 by 2. So plus or minus, here is 49 plus 576, root 625, that is 25. 25 plus 7 by 2 plus I into, this is 25 minus 7 by 2, that is equal to plus or minus 13 minus 5. 13 minus 5 is 8. 8 by 2, 4. Root 4 is 2. 2 plus this value. This is again root this value is root 9. Root 9 is, this is 3i plus this is also root 25 plus 7. This is 32 by 2, 16. 16 is, this is 4 plus I into 25 minus 7. 18 by 2, 9 is 3. 2 plus 4 plus 3i. Here this value is given negative real number. So take negative values all, that is minus 2 minus 3i minus 4 minus 3i. So this is, so that is equal to, that is minus 6 minus 6i. That is equal to minus 6 minus 6i. Here this value is, this is minus, this is also minus, this is minus, this is multiplying by minus, this is plus 3i. Here 3i cancel, so that is equal to, this value is, so minus 2 minus 4, minus 2 minus 4 is equal to minus 6. This is the required answer. This is 10th problem from complex numbers. Here is given alpha comma beta are two non-zero integers and z is equal to alpha plus I beta into 2 plus 7i. Is purely imaginary number, then the minimum value of mod z square is dash. Here is purely imaginary number means real part is equal to 0. This is the formula. So z is given, that is z is equal to alpha plus I beta into 2 plus 7i. Real part means this is alpha into 2 and I beta into 7i. This is the real part. Real part is equal to 0. Real part is equal to 0. This is 2 alpha plus I into I square minus 7 beta is equal to 0. From this 2 alpha is equal to 7 beta, this is written as alpha by 7 is equal to beta by 2. From this alpha value is taken as 7 and beta value taken as 2. Now we find mod z. that is mod z is equal to, this is modulus of alpha plus I beta plus modulus of 2 plus 7i. So this is mod of alpha plus I beta. This is under root of alpha square plus beta square into under root of, this is 2 square 4, 7 square 49. Alpha square, alpha is 7. This is 49 plus 2, beta is 2, 4. This is 4 plus 49. 4 plus 49, 49 plus 4. This is root 53 whole square, that is equal to 53. Mod z is equal to 53. Now mod z square is equal to, that is 53 into 53. That is equal to, multiplying this value is 2809. This is the required answer. This is next question from complex numbers. Here is asking the multiplicative inverse of z is dash. This is EAMCET 2023 question. So now we find multiplicative inverse of z is, the multiplicative inverse is equal to, inverse of z is 1 by z. So this is, take rationalization, that is z bar by z bar, that is equal to z bar by z into z bar. We know that is equal to z bar by z into z bar is mod z whole square. This is the multiplicative inverse of z. This is next question from complex numbers. Here is given minus 3 plus I into x square y and x square plus y plus 4i are complex conjugates. Then x is equal to dash. This is EAMCET 2023. Here is given minus 3 plus I of x square y and this value x square plus y plus 4y are conjugate complex numbers. That means this is equal to x square plus y. Take a conjugate for this, that is plus 4i is written as, this is minus 4i. These are the conjugate complex numbers. Take in place of plus minus. Now equating real parts, that is x square plus y is equal to minus 3. And equating imaginary parts, x square y is equal to minus 4. From this y is equal to minus 4 by x square. Substituting y value in this equation, x square plus y is minus 4 by x square minus 3. So observe this equation, x square minus 4 by x square is equal to minus 3. So x value is, so for suppose substituting x is equal to 1 minus 4 by 1, that is equal to minus 3. Equation is satisfied. That is x square value is 1. From this x is equal to plus or minus 1. This is the required answer. This is next question from complex numbers. Here is given z1 is equal to 2 plus 5i and z2 is equal to minus 1 plus 4i and z3 is equal to I. Then the value of mod of z1 minus z3 by z3 minus z2. So we know that the formula modulus of z1 by z2 is equal to mod z1 by mod z2. This is the formula. So applying this formula, that is modulus of z1 minus z3 by z3 minus z2 is equal to, that is mod of z1 minus z3 by mod of z3 minus z2. Here z1 is given, that is mod of z1 is 2 plus 5i, z3 minus I by z3 I minus z2, multiplying by minus, this is plus 1 minus 4i mod of, that is equal to mod of 2 plus 4i by mod of here 1 minus 3i. So modulus of this is mod of x plus iy is equal to, this is the formula, root over x square plus y square. Applying this formula, this is under root of 2 square 4, 4 square 16 by under root of 1 square 1 minus 3 whole square is 9. This is root 20 by root 10. That is equal to root 20 is 10 into 2 by root 10. Here root 10 cancelled. That is equal to root 2. This is the required answer. This is 14th problem from complex numbers from EAMCET. Here Z1 is given, that is 2 minus 3a, and the roots of the equation z cube plus bz square plus cz plus d is equal to 0 are I, z1 and z1 bar. Then b plus c plus d is equal to dash. This is the question. Here is cubic equation is given. Here is this is the first root alpha, and this is second root beta, and this is third root gamma. Here z1 is given, that is z1 is 2 minus 3i. So second root z1 bar is conjugate of this value, that is 2 plus 3i. This is z1 bar. Here alpha is given I, and beta is 2 minus 3i, and gamma is 2 plus 3i. Here cubic equation b value is equal to, this is the formula, sum of the roots, that is alpha plus beta plus gamma, that is equal to, so b is equal to minus sum of the roots, that is minus of alpha, that is I, plus beta 2 minus 3i plus gamma, this is 2 plus 3i. Here 3i cancelled, that is 2 plus 2 4 plus I, that is equal to minus 4 minus I. This is the value of b. And c is equal to product of the roots taken 2 at a time, that is alpha beta plus beta gamma plus gamma alpha. Alpha is I into 2 minus 3i. Beta gamma, this is 2 minus 3i into 2 plus 2 plus 2 alpha I. Multiplying by I, this is 2i minus 3i square, this is plus 3, 2 minus 3i into 2 plus 3i into a minus b, this is 4 plus 9 plus, this is 2i plus 3i square is minus 3. Here minus 3 plus 3 cancelled, that is equal to 4 plus 9 13 plus 2i plus 2i, this is 4i. 13 plus 4i, this is the value of c. And value d is equal to product of the roots minus product of the roots, this is alpha beta gamma, this is minus I into 2 plus 3i into 2 minus 3i. So this is equal to minus I into 2 plus 3i into 2 minus 3i. This is a plus b into a minus b, a square minus b square. This is 4 plus 9, that is equal to minus 13i. Now we find b plus c plus d, that is b value is minus 4 minus I, c value, this is 13 plus 4i, this is minus 13i. This is 13 minus 4, this is 9. Here is 4i minus 13i minus I, this is 14i minus 14i plus 4i, this is minus 10i. This is the value of b plus c plus d, 9 minus 10i. This is 15th question from complex numbers. Here is given the modulus of the conjugate of z, that is minus 2 plus I by 1 minus 2i whole square is. First find the conjugate of this. So z bar conjugate of that value is equal to minus 2 minus I by 1 minus 2i is, this is 1 plus 2i whole square. Now find the modulus of this. Modulus of z bar is equal to under root of this is minus 2 whole square plus minus 1 whole square by. So this is 1 plus 2i under root of 1 square plus 2 square whole square, that is equal to under root of 2 square is 4 plus 1 by under root of 1 plus 4 whole square. Here square root cancelled. This is root 5 by 5, that is equal to the modulus of the given complex number. This is next question from complex numbers. This is APMCET. Eapcet 2023. This is the question. Here is given for real numbers a and b. If 4a plus I into 3a minus b is equal to b minus 6i, and z is given a plus b by 4 into I, then find mod z by a is equal to dash. This is the question. Here is given relation is 4a plus I into 3a minus b is equal to b minus 6i. So equating real parts, that is 4a is equal to b, and equating imaginary parts 3a minus b is equal to 6 minus 6. So substituting b value in this is 3a minus 4a is equal to minus 6. From this minus a is equal to minus 6, a is equal to 6. This is the a value. Substituting in this, b is equal to 4a. So 4 into 6, that is equal to 24. So b value is 24. And z is given, that is z is equal to a plus b by 4 into I. Here a value is 6, b value is 24 by 4 I. Here 4 6 times cancel. Therefore z is equal to 6 plus 6i. Now we find mod z by a, that is equal to mod z. Z is 6 plus 6i by a value is 6. So this is, take 6 common, this is 1 plus I by 6. Here 6 cancelled. Modulus of this is 1 square plus 1 square, that is equal to root 2. This is the mod z by a is equal to root 2. Next question, the number of all possible solutions of the equation q plus z bar is equal to 0. Find the number of all possible solutions of the equation zq plus z bar is equal to 0. Here we are taking z is equal to x plus iy. That is, z is equal to take x plus iy, and z bar is equal to conjugate of this is, that is x minus iy. Substituting in this, z cube, this is x plus iy whole cube plus z bar is x minus iy is equal to 0. So a plus I whole cube that is x plus iy whole cube is equal to, this is a plus b whole cube, this is x cube plus I cube y cube plus 3x square into iy plus 3iy whole square plus x minus iy is equal to 0. Write down the real and imaginary parts. Here real parts is x cube, and this is 3x into iy square. This is I square is minus 1. This is minus 3xy square plus x. These are the real part. And write down the imaginary parts. Plus I of, here I cube is minus I. This is minus y cube. 3x square into iy. This is plus 3x square y. Here is minus y, that is equal to 0. So 0 means this is 0 plus I0. Equating real parts, that is x cube minus 3xy square. Second equation, that is minus y cube plus 3x square y minus y is equal to 0. From this take x common. This is x square minus 3y square plus 1 is equal to 0. From this x is equal to 0 comma x square minus 3y square plus 1 is equal to 0. From second equation take minus y common. This is y square minus 3x square plus 1 is equal to 0. From this y is equal to 0. This is y square minus 3x square plus 1 is equal to 0. Here is one point x is equal to 0 and y is equal to 0. This is one solution, that is first solution is 0 comma 0. Now find second, equating these two. So from these two equations 1 and 2, here first equation is, that is x square minus 3y square plus 1 is equal to 0. This is y square minus 3x square plus 1 is equal to 0. Subtracting these two equations, x square minus of minus 3x square, this is 4x square. This is minus 3y square minus y square. This is 4y square. Here 1 minus 1 is equal to 0. From this, x square minus y square is equal to 0. This is x. This is plus or minus y. So substituting x is equal to y in first equation. In first equation, that is first equation is x square minus 3y square plus 1 is equal to 0. Put x is equal to y in this. This is minus 2x square plus 1 is equal to 0. X square is equal to 1 by 2. X is equal to plus or minus 1 by root 2. Similarly, y is equal to also plus or minus 1 by root 2. Here one point is 0 comma 0 and other point is x comma y is equal to plus or minus 1 by root 2 plus or minus 1 by root 2. Here is 4 points is there. So take both plus and plus minus minus plus minus by. Here from 4 solutions and 0 0 1 solution. So the number of solutions is equal to 5. Number of solutions is equal to 5. This is next question. Here is given if mod of z minus 2 by z, that is equal to 2 is given. Then the greatest value of mod z. Now we find the greatest value of mod z. So mod z here, mod of z minus 2 by z is equal to 2 is given. This is the given relation. Now we take mod z. Now we find mod z. Mod z is written as mod of z minus 2 by z plus 2 by z. Add 2 by z and subtracting 2 by z. This is written as, that is equal to, mod of this value is equal to, which is are equal to mod of z minus 2 by z plus mod of by z. Here mod of z minus 2 by z value is given, that is 2. Mod z is equal to 2 plus, this is 2 by mod z. Take LCM. This is mod z square plus 2 mod z, that is equal to 2 mod z plus 2. So this is mod z square minus 2 mod z is less than or equal to mod z, which is less than or equal to 2. Add 1 on both sides. This is mod z square minus 2 mod z plus 1, which is less than or equal to 2 plus 1. So this is mod z square minus 2 mod z plus 1 is, this is mod of z minus mod z minus 1 whole square, which is less than or equal. From this, mod z minus 1, which is less than or equal to root 3. Mod z minus 1, which is less than or equal to root 3. From this, mod z, which is less than or equal to 1, root 3 plus 1. So greatest value of mod z, that is greatest value is equal to root 3. This is next question. if capital C is a point on the straight line joining the points capital A minus 2 plus 3i and capital B 3 minus 4i lie on the orgone plane and AC by CB is equal to 1 by 2. Then the argument of C is dash. This is EAMCET question 2023. Here C point is given, that is line joining the points, that is AC by CB is equal to 1 by 2 is given, that is AC is to CB is equal to 1 is to 2. That means the point C lies on the line segment AB. It divides in the ratio 1 is to 2. So the point C, now we find the point C. C is equal to, this is ratio formula, that is mx2 plus nx1 by m plus n. That is 1 into B plus 2 into A by 1 plus 2. This is the formula for finding the C. This is B. B value is given. This is 3 minus 4i plus 2 into A value minus 2 plus I by 1 plus 2 is 3. So this is equal to, this is 3 minus C is equal to, this is 3 minus 4i minus plus 2 into minus 2. This is minus 4 plus 2i by 3. C is equal to 3 minus 4 minus 1 minus 4i plus 2i. This is minus 2i by 3. Now we find the argument of C. Argument of C is equal to, we know that this is minus 1 minus 2i. This point belongs to Q3. So now we find argument in third quadrant Q3, that is minus of pi minus, this is tan inverse of 2 by 3 by 1 by 3. Here 3 cancel, that is equal to minus pi plus tan inverse 2. This is the argument of the point C. This is next question. Here is Z is given. Z is equal to 1 minus I whole cube into x plus iy. 1 minus I whole cube into x plus I. This is x plus I. This is the given x plus I. Is purely imaginary number for x. Z is purely real number for x is equal to x2. Then x1, x2 is equal to dash. This is the question. Here Z is given, that is equal to, Z is equal to 1 minus I whole cube. This is 1 minus 3i plus 3i square plus I cube. This is minus I cube. This is minus I cube into x plus I. This is equal to, this is 1 minus 3i. I square is minus 1. This is minus 3. I cube is minus I. This is plus I into x plus I. So that is Z is equal to 1 minus 3 minus 2 minus 2i into, this is x plus I. Multiplying these two, this is minus 2x minus 2xi minus 2i minus 2i square. This is plus 2. That is equal to, this is here real part is, that is real part is 2 minus 2x and imaginary part take minus I common. So this is plus I take common, this is minus 2x minus 2. Here Z is given, Z is taken as x plus iy. Here you given purely imaginary number for x is equal to x1. Imaginary number means real part is 0. Real part 0. Real part 0 is, that is 2 minus 2x is equal to 0. From this x is equal to x1. X is equal to 1. And imaginary purely real number means imaginary part is equal to 0. Imaginary part is equal to 0. Here imaginary part is minus 2x minus 2 is equal to 0. From 2x is equal to minus 2. Both sides 2 cancel, x is equal to minus 1. Here x1 value is 1 and x2 value is minus 1. Now we find x1, x2. x1 is 1, x2 is minus 1. That is equal to minus 1.